Jai Hind to all. My name is Divya Sharma. I am Assistant Professor in EC Department, Ajay Kumar Garg Engineering College. Now, my today's lecture is on coordinate system and transformation. There are of three types. First one is rectangular coordinate system, second is cylindrical coordinate system, and the third one is spherical coordinate system. Now, first is Cartesian coordinate system, or you can say rectangular coordinate system. Now, you can see this structure. Here is three coordinates, means in Cartesian coordinates x, y, z, and this structure is in 3D. Let us consider a point in this 3D Cartesian coordinate that is represented as P, and its coordinates are x, y, z. Now, x ranges from minus infinity to infinity, y ranges from minus infinity to infinity, z ranges from minus infinity to infinity. Now, let us consider a vector A in Cartesian coordinate that is represented as AX. AX, this is the unit vector of in x coordinate. AY, this is unit vector in y coordinate. Now, AZ is represented as unit vector in z coordinate. Now, its A vector is AX unit vector plus AY unit vector plus AZ unit vector. Now, second is circular cylindrical coordinate system. Now, it is represented is in x, y, z, but let us consider a point in cylindrical coordinate that is represented as P, and its coordinates are rho, phi, z. Here it is a point P that is represented as rho, phi, z. Now, rho, this is radial distance from z axis. Rho, you can see here, it is radial distance from z axis. Phi, measured from x axis in xy plane. This is your phi, this is angle is in xy plane, this is your xy plane. Now, z like Cartesian, as we have covered in the Cartesian coordinate, that is same z axis. Now, rho ranges from 0 to infinity, phi ranges from 0 to 2 pi, z its ranges from minus infinity to infinity. Now, let us consider vector A in cylindrical coordinate system, that is A rho, this is unit vector of rho, A phi, this is unit vector of phi, AZ, this is unit vector of AZ. Now, this is, let us consider this is the vector A in cylindrical coordinate. Here you can see these are your unit vectors. These are mutually perpendicular. If you want to find out magnitude of A, that is equal to under root A rho square plus A phi square plus AZ square. Now, here if you want to find out dot product of these unit vectors, so you can consider it like this: A rho into A rho, that is equal to A phi into A phi, means you can see A rho into A rho, that is equal to 1. And if A phi into A phi, unit vector of phi into phi, that is equal to 1. Unit vector of z into z is equal to 1. If it is not same, means these are different, A rho into A phi, A rho dot A phi, that is equal to 0. If it is also different, A phi dot AZ is equal to 0, AZ dot A rho is equal to 0. Now, here this is the dot product of these unit vectors. Now, this is the cross product. If you want to find out cross product, now you can see A rho cross A phi is equal to AZ, but if you will consider A phi into A rho, that is not equal to AZ, that is equal to minus AZ. Now, here A phi cross AZ, that is equal to A rho. If you want to consider it like this, AZ cross A phi, that is equal to minus A rho. Now, the third one, unit vector of Z into A rho, that is equal to A phi. Again, if you are considering in reverse direction, means you are considering here A rho cross AZ, that is equal to minus A phi. Now, you can see if first already we have covered the coordinates of Cartesian, cylindrical and spherical. Now here you can see cylindrical coordinate transformation. Now here this is a point in cylindrical coordinate. This is a point in Cartesian that is represented as P, X, Y, Z. This is a point in rho, phi, Z. Now here you can see this is the structure of here we can represent Cartesian and cylindrical. Now you can see X, Y, Z. Here you are considering this point, that is this one is represented as in Cartesian. If you are considering X, Y, Z, now here rho, phi, Z, these are the coordinates of cylindrical. Now here you can see this is X axis. Now here consider parallel to this X axis, that is represented as X is equal to rho cos phi. Why you are considering it? You can calculate it like this. These three axes are perpendicular to each other, and if you are considering here this is parallel to this one you are considering here parallel to this Y axis. Now here this one is also perpendicular to this line. Now this is your 90 degree, this is your angle represented as phi. Now here if you want to find out this axis, now you can see this is phi, in front of phi, that is represented as perpendicular, and if here is 90 degree, its front axis is hypotenuse. Now you can find out here y is equal to rho sin phi according to your angle phi and 90 degree, and here now you can find out x, that x is equal to rho cos phi. Okay, now these are the coordinates you can find out by using this figure. Now this is z axis, this is parallel to this line. Now here you can see x is equal to rho cos phi. Here you can find out by using this figure. Y is equal to rho sin phi and z is equal to z. Now here x is equal to rho cos phi and y is equal to rho sin phi. Now you can see here x square is equal to what? Rho square cos square phi, and if you are squaring this y is equal to rho square sin square phi. Okay, now x square plus y square is equal to what? This is equal to this one, because cos square phi plus sin square phi, that is equal to 1. Already you know this one is plus, this one is sin square phi, that is equal to 1. Now you are getting here this. If you want to find out rho is equal to, that is equal to under root x square plus y square. This is rho. Now you can see here rho is equal to under root x square plus y square. This is point conversion. First if you want to start with transformation, so we have to start from point conversion. Now you can see these are the points you are getting from this figure. Now can you convert it in, these are the coordinates of cylindrical. Now these are the x, y, z are in rectangular, or you can say Cartesian. Now if you want to convert it from Cartesian to cylindrical, or if you want to convert it in from cylindrical to Cartesian, now you can use these formulas. Now phi is equal to, here you can see x upon y, means rho is cancelled out. You will get here cos phi upon sin phi, means y upon z. You can find out phi from these two formulas, and z is equal to z. So this is the way how you can convert point conversion from Cartesian to cylindrical and cylindrical to Cartesian. Now let us consider vector, that this is in form of Cartesian, that is represented ax unit vector of x, ay unit vector of y, az unit vector of z. Now here this is the vector of cylindrical coordinate. Now here a rho, this is unit vector of rho, plus a phi unit vector of phi, az unit vector of az. Okay, now you can see a rho, component of a along rho. This is component of a along rho. This is component of phi a along phi. This is component of z, component of a along z. Now a rho is equal to a unit vector of rho. Now you will get this value, and here you can calculate it like this. You all know ax into A rho is equal to cos phi, ay means unit vector of y and unit vector of rho, that is equal to sin phi, az a rho is equal to 0 by using this figure. Okay. Now you can put these values in this equation. Okay. Now you can put here cos phi, here you can put sin phi, this is equal to 0. So you will get the final result, that is a rho is equal to ax cos phi plus ay sin phi. Okay. Now you can calculate, similarly you can calculate it for a phi, here a into unit vector of phi, so you can represent like this, this is unit vector of a, now here a phi, so you can multiply this one, you will get this, multiply this component with this, you will get this component with this, you will get this. Now here also ax dot a phi is equal to minus sin phi, ay dot a phi is equal to cos phi. Using this formula, using this figure, you can see this is x, y, z, x, y, here this is phi, now here this is phi. So you can calculate it, these already you all know how to use hypothesis theorem. Now you can calculate it, minus this is equal to minus sin phi, this is equal to cos phi, this is equal to 0. So put all these three values in this equation. You will get here a phi is equal to minus ax sin phi plus ay cos phi. Okay. Now this is for phi. Now similarly you can find out for az, you will get this is equal to az. Now transformation of vectors, transformation of Cartesian to cylindrical, how you can convert Cartesian to cylindrical and cylindrical to Cartesian. Now here you can write down, these are the coordinates of a rho, a phi, az, these are the coordinates of cylindrical. Now here this is the matrix, already we have done in the previous slides, you can check. See here, this is for ax cos phi sin phi, here z is equal to 0. Okay. Now here you can see, here sin phi cos phi, and for z that is equal to 0, here az. Now put all these values here, cos phi sin phi 0, minus sin phi cos phi 0, 0, 0, 1. Now these are the coordinates of rectangular, or you can say Cartesian coordinate. Okay. Now you can put the values of this ax, ay, az, and you can find out the value of a rho, a phi, az. Or you can learn it like this. If you all know this is cos phi, sin phi 0. Now you can differentiate this cos phi, you will get here minus sin phi. Sin phi you can differentiate it, then you will get here cos phi, this is 0, and where you are getting here both 0, then you can add here 1. You can learn it like this, or you can calculate it like already we have covered in the previous slide. Now inverse of transformation, it means this is your RHS, right? This is your LHS. So you can write down this ax, ay, az here, and you have to take inverse of this matrix, that is equal to this. Means here you have to take inverse. If you want to calculate, if you want to write down this in left hand side, and if you have given values of this, then you can write down here. And inverse you can find out, this is the inverse of this matrix. So this is the formula how you can convert, or this is the formula and this is the formula how you can convert it from cylindrical to Cartesian or Cartesian to cylindrical. Now third one, spherical coordinates. Already we have covered in the previous lecture that how you can represent the point. If you have a point in spherical coordinate, then you can represent like this P, and its coordinates are r, theta, phi. R distance from the origin to point P. Now as you can see, this is your point origin and this is your point P. So this is the distance that is represented as r. Now theta, angle between z axis and the position vector of P. Now you can see this is your axis, z axis, and this is your point P. So angle between this is represented as theta. Now phi measured from x axis. You can see this is your x axis, and if you want to measure phi, so you can measure it from x axis, that is equal to phi. Now ranges for r, theta, phi. These are the coordinates of spherical coordinate, right? So r ranges from 0 to infinity, theta ranges from 0 to pi, and phi ranges from 0 to 2 pi. And this is the 3D structure of spherical coordinate. Okay. Now here, if you want to write, let it be, you have a vector in spherical coordinate that is represented as you all know, these are the coordinates in spherical. So a r, a theta, a phi. So can you represent it in vector form? You can write down it like this: a r, unit vector of r, a theta, unit vector of theta, a phi, unit vector of theta. If you want to find out the magnitude, then you can find out it like this: under root a r square plus a theta square plus a phi square. This is the magnitude of vector a in spherical coordinate. Now you can see these are the unit vectors a r, a theta, a phi, and these three unit vectors are mutually perpendicular. A r in the direction of increasing r, where your radius is increasing, you can consider its direction is in the form in the increasing of r, and theta in the direction of increasing theta, and phi in the direction of increasing phi. Now if you want to find out the dot product and cross product of these unit vectors in spherical coordinate, now you can see r, theta, phi. If a r, unit vector r, and unit vector r, you are taking dot product of these two, then you will get here 1. Means if you have same coordinates like a theta dot a theta, that you will get here 1, and a phi dot a phi, that is equal to 1. But if you have different unit vectors a phi in dot a theta, then you will get here 0. Similarly, a theta dot a phi is equal to a phi dot a r, means both are equal to 0. Okay. So this is the representation of dot product of these unit vectors. Now if you want to consider cross product, now a r cross a theta is equal to a phi. If you want to find out a theta cross a r, that is equal to minus a phi. Now a theta cross a phi, that is equal to a r. Again, if you are taking a phi cross a theta, that is equal to minus a r. Now here a phi cross a r, that is equal to a theta. Now if you want to find out a r cross a phi, that is equal to a theta. Or you can consider like this: this is a r, a theta, a phi. If you are taking it a clockwise direction, if a r dot cross a theta, that is equal to a phi cross a r is equal to a theta cross a phi is equal to a r. If you are considering in anti-clockwise direction, then you will get the value in negative form. Now here this is the spherical coordinate. Now you can see x, y, z, and you have a point in, this is in Cartesian form, this is in cylindrical form, and this is in spherical form. As you all know, this is in Cartesian x, y, z, your point representing cylindrical r, theta, phi, and if you are representing a point in spherical coordinate, then you can represent it like rho phi z. Now if you want to find out its r, now you can see r is equal to under root rho square plus xz square, and you all know in previous slides already we have covered rho square is equal to x square plus y square. So put this value here, rho square is equal to x square plus y square, you will get here r is equal to under root x square plus y square plus z square. Now you can find out theta is equal to tan inverse rho upon z by using this figure, and here you can put the value of rho here x square plus y square, you will get theta is equal to tan inverse under root x square plus y square. Here you can see rho square is equal to x square plus y square, put here this value upon z. Okay. Now phi is equal to tan inverse y upon x. Already we have covered how to find out phi in the previous slide, previous in cylindrical coordinate. Okay. And you can see from this figure you can find out x is equal to rho cos phi. You can see here this is your phi, this is 90 degree. So 90 degree case in front of 90 degree you will get here rho. So rho is here your 90 degree. This is your hypotenuse, this is your perpendicular, this is your base. According to that, you can find out x is equal to rho cos phi, and rho you all know, that is already we have discussed in the previous slide, r sin theta, or you can find out from this figure y is equal to rho sin phi, here x is equal to rho cos phi. So put these values here in this equation, then you will get x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z is equal to r cos theta. So this is the point conversion of cylindrical, Cartesian to spherical. Now these are the vector, how you can write down vector in Cartesian form and r theta phi, that is in spherical coordinate. Now you can write down it like this: a is equal to ax, unit vector of x, ay, unit vector of y, az, unit vector of z. Now here this is in spherical coordinate, so write down vector that is in form of ar, this is unit vector of r, a theta, unit vector of theta, a phi, unit vector of phi. Okay. Now put here the values of ar is equal to a into unit vector of r. So put the value of a and ar here. So you will get this. Now a theta if you want to find out, so a dot unit vector of theta. So put these values here, and the previous values already we have done, like x is equal to r sin theta, y is equal to r sin theta sin phi, z is equal. So all these values you can put it, and you will get here ar, a theta, and a phi. Now if you want to do transformation from, this is your r theta phi, so these are the coordinates of spherical, and ax, ay, az, these are the coordinates of Cartesian. Now if you want to do transformation in between Cartesian and spherical, so write down here coordinate of sphericals ar, a theta, a phi. Now here write down the matrix, already we have done in the previous slide, sin theta cos phi, sin theta sin phi, cos theta. Now here cos theta cos phi, cos theta sin phi, minus sin theta, here minus sin phi, cos phi, and 0. So here if you have given these values ax, ay, az, so you can find out ar, a theta, a phi by using this matrix. Now if you vice versa, if you want to find out now ax, ay, az, you want to find out, write down here ax, ay, az, and inverse of this matrix. So write down here inverse of this matrix means if you have this column, so write down this column in form of row. So sin theta cos phi, write down here sin theta cos phi, cos theta cos phi, write down here cos theta cos phi, minus sin phi, minus sin phi. So if this is your first column, this is your first row of this matrix. Now this is your second column, write down here in form of row in the second row. Now here this is the third column, write down here in the third row, and write down here ar, a theta, a phi. If you have given all these values ar, a theta, a phi, so you can find out ax, ay, az by using this matrix. Now let it be you have 2 points r2, let it be you have 2 points, like this is r1, this is r2. Okay, now you want to find out distance between these 2 points with position vectors r1 and r2, that is equal to d is equal to magnitude r2 minus r1. Now if you want to find out in Cartesian form, then you will get here d square is equal to x2 minus s1 square plus y2 minus y1 square plus z2 minus z1 square. This is in Cartesian form. Now you all know in cylindrical form x is equal to rho cos phi, y is equal to rho sin phi, z is equal to z. So put these values and you can find out the d square distance between 2 points in cylindrical form. You can put all these values and you will get this answer. Okay. Now in spherical, as you all know, x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, z is equal to r cos theta. Now put these values and find out d square is equal to this one. So this is in spherical coordinate. So by using these formulas you can find out distance between 2 points. Now let us take an example. You have a point, given point that is minus 2, 6, 3 and a vector, given vector that is y ax plus x plus z ay. Now express p and a in cylindrical and spherical coordinates. Now second part is evaluate a at point in the Cartesian, cylindrical and spherical system. See, this is the point. So here you can see x is equal to -2, y is equal to 6, z is equal to 3. And if you want to find out in, this is your point, given point. Now if you want to find out in cylindrical, so you all know the formula, rho is equal to under root x square plus y square. So put the value of x and y from here to this equation is formula, and you will get this value. Now phi is equal to tan inverse y upon x. You all know this formula in cylindrical form. So put the value of y and x, you will get this angle, and z is equal to 3. Now in form of cylindrical, you all know r is equal to under root में x square plus y square plus z square. Put the value of x, y, z, you will get the value of r. In spherical, now theta if you want to find out, so tan inverse under root x square plus y square upon z. Now you can put the value of x, y here, and z, you will get the angle of theta. And phi already we have done in the cylindrical. So phi is same of cylindrical and spherical. Now this is your point -2, 6, 3, and you can see your point rho is equal to, if you want to write down in cylindrical form, so rho is equal to this one. Now 1 point, this is your phi angle. Now this is your z in cylindrical form, and if you want to represent it in spherical, then you can represent it in this form while you are finding these values r, theta and phi. Now you want to do the transformation. Already you all know in the question that ax, this is y, this one is in form of unit vector of y, that is x plus z. So put these values here in this transformation. You all know how to find out. Here you have to find out a rho, a phi, a z. So these are the coordinates of cylindrical, right? And you all know the matrix for this. And here you can put the value of ax, ay, az, and these values are given in the question. Then you can see ax is equal to y, ay is equal to x plus z, and az is equal to z. So put these values here, and you can find out a rho is equal to this, a phi is equal to this, az is equal to 0. Okay. Now already we have done in the previous slide that you all know x is equal to rho cos phi, y is equal to rho sin phi. Now if you want to find out in form of rho, you can find out by using these values. You can put all these values and you can find out the a rho, a phi, az. So in this form you can find out. Okay, and you have given values. Rho is equal to 6.32, already we have calculated in the previous slide. Phi is equal to this and z is equal to this. So you can put these three values in this equation, and this equation you are obtained from this matrix, right, from this transformation matrix. Now you will get, finally you will get at point P, this is the A vector. That is, while you are putting these values in this equation, you will get this. Okay. Now in spherical system, you have given values, this one y, x plus z, 0, and you have given matrix. You can similarly you can find out for ar, a theta, a phi, and you have given values. This one already we have done in the previous slide, we have calculated these values. So put all these values, you will get this for spherical coordinate. Now you all know magnitude of all the three coordinate systems are same. Now let us check. If you want to check this magnitude, how you can check? Now you can check under root minus 0.857 square plus, this is the value, minus 0.4066 square plus minus 6.008 square. means under root of all these. So you will get here 6.083, and you can check for cylindrical, and spherical. So this is the way how you can calculate or you can do transformation of Cartesian, cylindrical and spherical. Thank you. Next topic we will cover in the next video lecture.